Okay, good morning. This is Professor David J. De Los Reyes. Okay, what I will be presenting this morning will be oh, I set up the charging of a 3.7 volt lithium battery coming from the battery pack. This is 3.7 volt, 3.7, 3.7. This is the positive side connection. These are all soldered on the side. This is the negative side connection. They are all soldered on the side. And I am now charging this one by using my, what do you call this, assembled variable DC power supply. I injected in an 8.88 volt to charge this 3.7 volt. Okay, it is greater than the voltage of this one, so the charger could drive a 120 milliampere current on the battery. So right now, if the charging voltage is 8.88, the total charging current passing through the battery, 3 batteries, is 120 milliampere. So 120 milliampere, they are connected in parallel, right? So 120 divided by 3, that will be, each of these will be 40 milliampere, 40 milliampere, 40 milliampere, 40 milliampere, such that the total current coming from the red wire emanating from the regulated power supply, which I did it myself. It's a variable thing. It's 120 milliampere, so this passes 40 milliampere, 40 milliampere, 40 milliampere, and this black thing here goes back to the power supply. Okay, so this is now the setup of the charging process. I removed this one from the battery pack for the charger of a cell phone. The connection, we are still using the USB thing, but I want to use this one for some of my electronic projects. That's why I am charging this one. I am charging this one, so I could use it with my electronic projects. Like right now, I connected a combination of a voltmeter and ammeter, okay, in regards to the charging process. This 8.88 is actually the voltage coming from the regulated power supply, and the lower reading is actually the current passing through the battery, which is given by the regulated power supply. It's 120 milliampere. So this instrument here is a combination of a voltmeter and ammeter. So when we are charging, at least we know what's the input voltage and we know what is the total current charging the battery. That's the importance of this one. So for now, this is just a good setup. I will be using this one for some of my electronic project. Okay, so instead of charging these three batteries by using the USB charger like before, I removed the USB connector. I threw it. Anyway, I am an electronic enthusiast, so I could do the charging without the USB connection. Anyway, I am using this one for some of my electronic project. Okay, I think that's more than good enough for tonight. So what I have shown you guys is that this is the charger, this is the voltmeter and ammeter instrument which monitors the applied voltage on the battery to be charged, and so with the charging current. So right now the charging voltage is 8.88 and the charging current is 120 milliamperes. Actually, we could increase the voltage by just rotating this one. It doesn't hurt. It doesn't hurt. I increased the voltage to 12.4. Okay, but this might be high enough maybe. I don't want to destroy the battery, you know. What I am after it is that the charging current, I want to increase the charging current. Okay, so 8.51 will be fine. Okay, 110 milliamperes. The significance of this reading here is when the charging current is 0, we could say that the battery that is being charged is already fully charged. So as long as there is a current reading here, the battery is not fully charged. Okay, so when this is 0, we could say that the battery is already fully charged. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.